Hi everybody, this is Miss Abbott talking to you through the magic of technology from the past. Right now I'm hopefully playing with my teammates and beating a team from New York at the Frisbee game and representing you all well. But what I'm going to teach you about right now, my time, is making position versus time graphs of motion. And we're just going to do one direction, the same that we've been doing for the past week or so in class. So I've got two representations. I've got a table and a diagram, and I'm going to focus on this diagram for a moment. What you can see is a buggy moving from 0.2 meters to 1.6 meters, and this is exactly what I did with the buggy last week in class. So we can see at 0.2 meters, the buggy's at t equals 0. At 0.57 meters, that's where it was at t equals 1. At t equals 2, it was at 0.94 meters. T equals 3 at 1.31. And then once it got to 1.6 meters, I stopped it, and that's the stopwatch read 3.8 seconds at that time. So this data table shows that same exact information. We've got time over here and the position over here, and you can see I labeled time in seconds and position in meters just to be really, really clear. I always like to put units on everything. So I'm going to change this into a graph. And there it is, my buggy motion graph. What you can see about my graph is that I have a title. Titles are very important, otherwise you might not know what the graph is about. I've got a y-axis drawn and an x-axis drawn. And you can see that I made my intervals for where I put my numbers spaced out appropriately so that my graph is nice and squarish, and the graph fills the whole page, fills the whole graph area, this line. I have labeled these axes with the thing that is on it, including the units. And you can see time is on the x-axis. Time will always, always be on the x-axis anytime we make a graph that involves time, and I've said time in seconds. And then over here on the y-axis is position in meters, and that position in meters, that's the other information we have. So I plotted the points based on this table. So the first point was 0 and 0.2 meters. So I went here to 0 seconds and went up to 0.2 meters and plotted the point here. You will notice that this point is also the y-intercept. So that the y-intercept is where the motion started in the case of this graph, because we started at 0 and 0.2 meters. So if I was going to make an equation for this to describe this motion, I would use that as a part of my equation. And then we've got all of these points going up that I plotted based on this data here. And I'm super lucky because the buggy moved in a very straight line. So you can see this is a nice straight line. It is a linear kind of motion. So I can actually calculate the slope by taking the y value for this point and subtracting the y value for this point from it, and dividing that by the x value for this point, and divided by the x value for this point minus the x value for this point. And that's just finding the rise over the run. So if I wanted to make an equation, I have all the information that I need to. What you're going to do now is, in pairs, you are going to make a graph like this based on the motion of your two different wind-up toys. So you'll have a line for one of them and another line for another one of them. I suggest maybe you work together with your partner, so split the load evenly, figure out ways to make it so that each of you is plotting a similar number of points. Obviously the monkey or creepy clown will have a lot more points than the snail will. Those wind-up toys did not move in this nice linear motion. They all slowed down a little bit. So you won't be able to draw this beautiful straight line through your points. I don't expect that. But you will be able to plot a bunch of points and show what the motion of the thing was like, and you can connect the dots. It just won't be a straight line. After that, you're going to go through a worksheet that has some different scenarios in it for you to graph and change things around between different representations, like these kinds of diagrams or tables or maybe a written description, or even motion maps. So good luck. Be good, be kind to the sub, and I will see you all on Monday.